Alright, so today's seminar is going to cover combining like terms. Our goal, or our I can statement for today, is I can simplify algebraic expressions by combining like terms. Leave this here for you to copy into your notebook. If you want to pause the video, that would be helpful. So the note sheet you will be getting will be looking like this. So before we really get into problems of combining like terms, we need to define what like terms are. So in these three boxes up here on your note sheet, what I want you to put there is so in order to be defined as a like term, a term must have the same variables, must have the same exponents, and the last one is that the order doesn't matter. And I'll get into that a little bit later, but what I mean by order doesn't matter is within a specific term, when you're deciding whether or not they can be put together, the order in which the variables are in doesn't matter. As long as they have the same variables and the same exponents, they can be combined together. So make sure you do write these down here and zoom in a little bit for you. So in order to be a like term, they must have same variables, same exponents, and the order doesn't matter. And just another couple of side notes before we get into the actual problems with combining like terms. So first, it says here that to combine like terms, add or subtract the coefficients. And if you don't know, coefficients are the number that is in front of the variable. And what you'll need to do is keep the variables and the exponents the same. So let's say that two problems had an x in them, let's say a 5 and a 4. We would add the 5 and the 4, which would give us 9, and the x would stay the same. And secondly, another thing to remember, and this is a big one, this is probably where you might make mistakes. So if the coefficient is missing, remember that's the number in front of the variable, it is always a positive or negative 1, depending on which sign is out in front of it. And to expand on that, coefficients take the sign in front of them. So if there's a subtraction symbol in front of the coefficient, it's negative. If there's a plus in front of the coefficient, it's positive. Leave those there for a second. Might help to pause the video so that you can copy these down. Alright, then if you can get your pink note sheet back out. Now what we're going to do here is a little bit of a hands-on activity. So what you'll get is you'll get a white sheet of paper that has these three problems on them. And what you'll need to do is cut them out according to the sign that is in front of them. Just lay these out here real quick. I think we should have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are all the terms that are in that first expression up there. And what you'll need to do is you'll need to cut these apart. Now what I want to do is group these according to whether or not they meet the terms for like terms, or the requirements, I should say. So first and foremost, we need to make sure that they have the same variables, the same exponents, and the order doesn't matter. Well, since we have a negative 2x that starts here, I think what I'm going to do is start by grouping all of my x's together. So it looks like I have the negative 2x. And what you'll need to do is glue these on the sheet here. You'll have a negative 4x that also falls within the x. As you can see, they have the same variables, which is x. They do have the same exponents. It's just to the first power here. We don't see that though. And this problem doesn't really apply with the order, doesn't matter, but that will come into play in a little bit here. Our second problem, and we have a negative 15x that gets grouped with these. And what you want to do, like I said, is just glue these down so that you know that they go together. Now I think I'm going to move to, well, I see there's some that have x squared in these, or x to the second power, so I think I'm going to group those. So it looks like I have two of those. I have a negative 4x squared and a 2x. And then we need to, and as we can see, we just have left, and these, what we call these, are constants because they don't have any variables tied to them. So we would group all of our constants together. So we're not quite done yet. What we'll still need to do is go through and combine these terms. So we have, as you can see, we have a bunch of x's here, we have a bunch of x squareds here, and we have our constants here. So your integer operations are going to come into play again here. Those don't really go away like I mentioned. So what we'll need to do is, we'll start with our negative 2x, or our x's here, our x terms I should say. Let's start with those, and we're going to add those together. So a negative 2x plus a negative 4x plus a negative 15x. So I have three negatives that I'm adding together, which should give me a bigger negative. So let's do negative 2 plus negative 4 first. Negative 2 plus negative 4 would give me a negative 6, and then plus a negative 15 would give me a negative 21. So all in all here, I have negative 21 x's. So I'm just going to write that down. And I'm not going to put a sign here yet for the next group of problems that we put because I don't know if it's going to be positive or negative. So let's look at the x squareds here. So I have a negative 4x squared and a 2x squared. So remember, I'm just looking at the coefficients here and keeping the variables and the exponents the same. So really I'm looking at a negative 4 plus 2. So if I have negative 4 and I add two positives to it, that would give me a negative 2. So the sign here is going to be a negative 2, and I will be left with an x squared. And then last but not least, we have the coefficients here. We have a 3, a positive 3, a positive 5, a positive 11, and a negative 15. So one thing that I do want to stress is that when you cut these out, make sure that the sign goes along with the, that's in front goes along with the number. So we should have a positive 3 and a positive 5, which would give us a positive 8, plus another positive 11 would give us a positive 19. And then if we subtracted 15 from that, we would get a positive 4. So our final term here that we should end up with after combining all the like terms is negative 21x minus 2x squared plus 4. Now here when we're ordering these, the order here doesn't matter either. So it's okay that I wrote it this way, but typically with with combining like terms, we want to put the term with the most variables as well as the highest exponents first and then work down to the coefficients. So really what I might have wanted to do is negative 2x squared minus 21x plus 4. But it really doesn't matter. So next problem then, let's work through that one. Go through the same process here. So I've cut out all of my terms, and we'll need to first order those. Alright, so I've laid out all my terms here. So I think what I'm going to do with this problem is look at the terms with the most number of variables and highest exponents in it first. So we'll order those. So what it looks like here is the terms with xy or yx. So here's where this order doesn't matter that I talked about. So yx and xy are going to be the same thing. So I'd have, first off, I would group together my 2xy, my xy, and this negative 3yx will go along with that, because if we were putting numbers in there, these all show multiplication, so it would end up doing the same operation on it. So that's why it's okay that these variables are mixed around. So I've done the xy terms, so now I'm going to try and order the next ones here. So the x terms, I'm going to have a 2x, a negative 3x, and an x that go together because they all have x's and they all have an exponent of 1, but we don't see that like I mentioned. And last but not least, we have our constants, so our numbers without variables. And then next here what we would do is combine the like terms. So you have to do your integer operations like I mentioned earlier. So if I have 2xy, negative 3yx, which is the same thing as xy, and a 1xy, so here's where we have the problem of there's no coefficient, but it's just a 1. There's just one group of xy here. So, and it's a positive one because of the plus sign in front of it. So if I add these together, I would have, well, I'm going to look at 2xy plus xy first. That's 3xy. If I do 3xy minus 3yx, that gives me 0xy. So I'm going to write that down. Really, though, since it's 0, you wouldn't even need this term. But just for the sake of going through this the first time, I'm going to keep that term. And then with the second ones here, I have 2x, an x, and a negative 3x. This one here is, since it's just an x, there's a plus. This was the first term here, but we can think that there's a positive x there. So I have 2x plus x, which would be 3x, and then minus 3x gives us something interesting here. We would have a 0x. So once again, we don't need those, but it doesn't hurt to write them down. And then last but not least, we need to combine our negatives here, our negative constants. So negative 2 plus a negative 9 would be negative 11. Negative 11 plus a negative 4 would give me negative 15. So a minus 15. So at the end, I have 0xy plus 0x minus 15. Or I could just write my final simplified answer as negative 15. And the reason for that is because there's no xy's and there aren't any x's. So those are gone. We don't even need to write that. Our final answer would be negative 15. So this whole big thing here, this big expression, just turns into negative 15 after combining the like terms. Now what I'd like you to do here is pause the video and try and do this last one on your own. And once you think you've gotten through it, check your answer, or play the video and check your answer with what I do here. So I'll go ahead and do that, but make sure you pause and try it. So after you've worked through this one, you should have grouped your 4xyz together, your 2zy, and 1yz here, because there's just a 1 in front of here, remember, since there isn't a coefficient, there's 1 there. And this order doesn't matter, remember. And then your x's and your constants. And down here your order doesn't matter again, but typically you do the most variables and highest exponents and work down all the way to the constant. So what you end up is 4xyz plus 3yz plus 5x minus 4. Now for like terms, remember you must have the same variables, same exponents, and your order doesn't matter. So I'm going to go ahead and take this out of here. Make sure you have this in your notebook and that you've glued down all of these problems that we've grouped together. So it'll be a great reference for when you're doing combining like terms in the future. And last but not least, just to reinforce what you've been doing, I do want you to do a couple more problems. So we'll do 2 more practice problems. And typically if you see these like this and you can't cut them out, what I like to do is draw lines between all of the variables and coefficients. So I'm going to go here, 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 here. So this just lets me, and I give the sign that's in front of them to the specific variable or constant that's there. So whichever term, make sure you give them the sign that's in front of it because you're going to need that to combine the terms together. So here it looks like I have 1, 2. So I'm going to use a couple different colors here to group these together. And what I think I'm going to do is start with the xyz's, and I'll do those in blue. So I have a positive 2xyz and a positive 9xyz. Then I think I'm going to look at the xy's here. So I have, looks like just a -1. Remember there's a -1 in front of there because the constant isn't there. And when the constant isn't there, it's 1. Or I'm sorry, the coefficient. It's the coefficient. There should be a -1 there. So a negative xy. Then I'll go ahead and do my x squareds. So I have a negative 5x squared. And I have a 2x squared. Remember, I'm following the guide on the pink sheet as to what like terms are. They have the same variables and the same exponents, and the order in which they're written doesn't matter. And last but not least here, I have a couple of constants. So I have a +7 and a -11. So I'm just going to double check that I got all the terms here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it looks like I have them all written down. So what I'm going to go through then now is using my integer operations, I'm going to add the coefficients, add or subtract them I should say, and keep all the variables and the exponents the same. So 2 plus 9 would give me 11, and then xyz is going to stay. Let's look at my xy term, which would just be the negative xy, since that's the only one there. Then the x squared terms, negative 5x squared plus 2x squared would give me a negative 3x squared. And then positive 7 minus 11 would give me a negative 4. So my final expression, where I can't simplify anymore by combining like terms, would be 11xyz minus xy minus 3x squared minus 4. You make sure you copy that one down. And we will do one more here real quick. And I want you to try this one on your own. Remember, draw lines between all of the different terms that we have, including the sign in front of them, so that you know whether it's positive or negative. So go ahead and pause the video here and try combining like terms on your own on this one. and compare your answer to mine once you have finished. Okay, so you should have paused the video and tried this problem. Now, after going through this, I had 1, 2, 3, 4, 5, 6 different variables, or I'm sorry, different terms, not variables. And so I had my ABs grouped together. I had a 5AB and a 7AB. I had a negative B and a positive B. I had a 2Z and a negative 1. So going through combining these, I'm just looking at the coefficients, remember. Exponents and variables stay the same. So 5 plus 7 is 12, and the AB comes along with that. For the B's, I have a negative B and a positive B. Those cancel each other out, so there's 0B. I could have written 0B down here, but it's not necessary because they're gone, so I just didn't include it down here. I have a Z term, so 2Z, and there weren't any other Z's. That just comes here, plus 2Z. And then the only constant I had was a negative 1, so I brought that down as well. So my final expression here would be 12AB plus 2Z minus 1. So make sure you have this problem copied down in your notebook, along with the 3 other problems that we worked through on your pink note sheet that should go in your notebook. And if you recall, what we were working on today was combining like terms, and our goal was I can simplify algebraic expressions by combining like terms. So hopefully after going through this set of problems, you're feeling better with combining like terms, and you are working towards, or you are able to meet this goal. If you have any questions, please feel free to ask me. I'm always available for help.